Let's take a look at the weather ahead for this week. A cold week ahead as the Arctic cold front has moved through today on Sunday with some snow showers and some snow squalls and the winds that were strong and gusty. So the cold air is coming in and it's going to linger for the remainder of the week. And one thing that I want to point out is what I was excited about a couple days ago that I had posted an image of this map. The overall upper level pattern is reminiscent of some of our better snowstorms over the time or over the years. So this has the potential, if all the pieces of the puzzle are fit together perfectly, to bring a sizable storm. In this case, for Tuesday, it will bring a storm. So the energy that had hinted to me that there would be potential for precipitation and the cold air in place is going to come to fruition, but there was a wavering back and forth on guidance on whether it was going to be a big storm or a weak storm. It's going to be more of a weak storm, but a storm nonetheless. So what I loved about this pattern is you have the ridge out west, basically a positive PNA, Pacific North American ridge. You have the negative EPO, which is a ridge over Alaska. Now, these are displaced a little to the west, but the general theme is with this ridge here and the ridge over Alaska, it draws down the cold air from the Arctic region, coupled with this polar vortex that's trapped under this block. This block is a negative AO, or Arctic oscillation, which is high pressure over the Arctic region, a negative NAO, or North Atlantic oscillation, which is high pressure over Greenland to Iceland, and that's called a blocking high. So this blocks the polar vortex, which is just a low pressure system that gets trapped over the Hudson Bay. And this helps draw this cold air, and it keeps reinforcing itself over the course of this week until it breaks down next weekend. So this type of setup usually allows energy to come down, dive down into the east of the Rockies, into the plains, tap some Gulf moisture, and come up the East Coast. And because of this blocking, and usually a trough over here by Newfoundland, it helps the systems stay offshore and allows the cold air to stay in place. So a lot of the check boxes have been checked for this system. However, let's take a look at some of the details, and you'll see why this will be a bit of a weaker system than a strong one. Whenever I'm analyzing the weather pattern, I'm always starting at the upper levels. This is 500 millibars. This is way up where planes fly in the air. And these are the steering currents to me. From this map, I can determine in my mind where surface high pressures, low pressures, which way the winds are going to be flowing at the surface. Where's the cold? Where's the warmth? Where are the systems? Now, you may not be able to look at this and ascertain that, but I'm just going to start with this like I normally would on my own and show you some things that jump out to me. So first of all, the energy that was coming onshore here in over Oregon is the energy for our storm on Tuesday. Now, I had noticed this on guidance several days ago, and put it in the back of my mind that if this all shaped out right, that we could be able to tap some Gulf moisture and bring it up the coast. So I put this into motion, and then this was wavering back and forth as far as a more vigorous trough, a sharper amplitude trough, where that would allow a bigger system, a surface low to form off the coast. But as you can see, everything's very stretched out. You have the Pacific jet, the energy from the Pacific jet here that crashed ashore Oregon. You have the polar jet coming down around the Hudson Bay vortex, the polar vortex coming down. If this was a clean phase, a sharper trough, this would be a much bigger system. Instead, it's just two sheared out, stretched out, more diffuse pieces of energy, but still energy nonetheless. And as these come across the plain states, it is pooling some Gulf moisture up the coast. Surface low forms around South Carolina, North Carolina border, and works its way up the coast just offshore, bringing precipitation first through the Tennessee Valley, lower mid-Atlantic, and then as it works its way north through the northern mid-Atlantic and New England. So the things I'm looking for, what I'd like to do is put this into motion and see what trends jump out to me. So let's take a look at that. This is going really fast, so it might be a bit of a blur to you, but this is the past 3 days or so for this particular model. And what we noticed is, well, even several days before that, this was a sharper trough, as I mentioned, but it got stretched out. But now it's the fine tuning, the little details of these height lines. Are they flatter, west to east? Are they more meridional, excuse me, which is south to north, or southwest and northeast? And if you can just tell just by following these trends, at one point it flattened, now it's a little bit of a southwest and northeast flow. It's subtle, but these subtle differences make all the difference as far as what the sensible weather will be for your backyard. So basically what we're seeing consensus-wise between this NAM model, which is a North American model, high res, and all the global models, GFS, European, all the models generally have a consensus for this type of look. So that wasn't the case. There were some that were stronger. The Europeans stayed this way pretty much the whole time, kind of led the way. So what we're dealing with is diffuse, stretched out, sheared pieces of energy with a partial phase of energy. You have some jet stream, jet assist with the subtropical jet that's eventually phasing with all of this energy. So you put it all together, you have moisture, you have some jet enhancement, you have warm air overriding a cold pool of air, a pretty deep cold pool of air, and that's a recipe for light to moderate precipitation. This is a look at the jet stream, and as these jet streams, you have a polar jet, a Pacific jet, and a subtropical jet, sort of phasing, and you see as they kind of interact with each other, you get these stronger winds, and these stronger winds, and there's more diffluence or spreading of the air parcels or the streams of air. What happens is that is aiding and enhancing the precipitation development, northward progression of that precipitation. So here's our low pressure that develops. So the energy is coming across west to east across the country. You have some partial phases of this stretched out energy. Low pressure develops South Carolina, North Carolina coast. The jet stream, because of the partial phase, now the subtropical jet stream is playing a part here, helps the low pressure deepen. You have the diffluence aloft, or spreading of the streams of air, for lack of a better way to put it, which helps enhance the precipitation. And as this slowly strengthens, it really doesn't get its act together completely until it's well past the Philadelphia area. But those pieces all together are helping the light to moderate precipitation work up our way. And for the simple and fun way to look at it, here is the surface map showing the rain, mix, and snow. And this is Monday afternoon, about 4 p.m. or 2 p.m. And so Monday afternoon, we'll just call it that. So what we see is the precipitation working in from the Tennessee Valley. So we'll start south of Philadelphia first. And then as the low pressure takes shape over the South Carolina, North Carolina border, it will start to push a warm front, or the subtly flow at the surface and just above the surface will start pushing that warm, moist air over that cold pool, and precipitation will break out. Now, I'm not saying this is exactly how it's going to be, but here we are at 8 p.m. on Monday. Snow is already starting. So Monday after sunset, overnight Monday into Tuesday will be the heaviest quote unquote snow. And what we have to watch now is, as far as the devil is in the details, the question is, will enough warm air work in above the surface to change the snow to mix or rain? And we think Delaware, extreme South Jersey, absolutely, which is not uncommon for when you have an onshore flow. Let's take a look at temperatures at the surface to give you an idea of how cold it is. So it's in the 20s, which is certainly plenty cold at the surface, but the question is, what's happening above the surface? So let's go up to just above the surface, about 5,000 to 6,000 feet. And we put this into motion. The freezing line is where the green meets the blue. So it's above freezing in the green, below freezing in the blue. And as that storm works closer, you can see it works easily inland over Delaware and New Jersey. Philadelphia, though, stays cold enough, at least at this level. So what we have to see then is, well, this shows 5,000 feet above the surface. This shows the surface itself. They both seem cold enough. But is there a warm nose, as is called, somewhere in the atmosphere that might cause the snow, as it falls through the atmosphere, to change to a different form of precipitation? Let's take a look by looking at the sounding, which is not available. That's not very helpful. Hang on. Okay, so here's the sounding, and what I want to point out is it's called a warm nose because it literally looks like the nose. If you're looking at the profile of a person, looks like a nose sticking out. So we had looked at 850, which is right here between 800 and 900 millibars. 850, look, it actually is. Oh, and the freezing line, I know this is a little tough to see if you're not familiar with it. So 0 is the freezing line, and it goes up here, this dashed line, going from here up to here. So as long as the temperature as the air parcel goes up through the atmosphere is below freezing or left of this line, it's going to stay snow. But look what happens as I put this into motion. You can see this is all snow now. This is Philadelphia. The next hour, that warm nose is getting closer to that freezing line. The hour after that, it is pretty much right on top of it. So still, as snow falls through the atmosphere here, it meets this, it gets close to melting and changing to rain, but still snow there. Let's go one more hour. Now look at that nose sticking out. So now we're above freezing at about 900 millibars. So that might be 2,500, 3,500 feet in the air. And as that snow comes down and gets to this layer of the atmosphere, it will melt and change to rain. But then it falls through that and comes down before it hits the surface. The surface is 29 degrees. So depending on the thickness of this warm nose, you're either going to have sleet. If the warm nose is even thicker, it'll change to a freezing rain. So I do, as of now, I think the wintry mix that the National Weather Service has outlined for the 95 region, Philadelphia and immediate suburbs, is feasible. It's possible. Depends on how close that storm system gets to the coast as it works its way up. Put it all together, I'm going to borrow the National Weather Service out of Mount Holly, their snow map, which aligns with what I'm thinking as well. And I like how they outline that area we were just looking at. So we were looking at the soundings of Philadelphia, and that warm nose is trying to work its way up. Other models have it staying all snow, even down to the interior ports of southern New Jersey. So the initial stream of precipitation will affect the Delmarva, will affect Delaware, extreme southern New Jersey. They can get an inch or two before Philadelphia sees its first flake. As that works its way north and the warm air comes with it, I expect that the change to rain at the shore, Cape May, down into Delaware beaches, and eventually change to a mix and possibly some rain in interior southern New Jersey. The tough part, as always, is the Philadelphia 95 region and immediate suburbs on either side. Certainly going to have a better chance to stay far more snow or all snow as you go farther north and west, and up in the Lehigh Valley, Berks County, and certainly the Poconos. It will be a fluffy snow with some pretty good snow growth. So it will accumulate for a couple hours at a decent clip, and it'll last for 12 hours plus or minus. So it's going to be a nice gentle snow overnight, some burst of moderate snow. All said and done, 1 to 3 inches is a general rule of thumb, especially from the city north and west. With some areas I would expect to see 4 inches, and we'll fine tune that at maybe 5. But really, it's going to be capped by the strength of the storm. Really doesn't take off until it's past our latitude and the precipitation is shut off. So starting late Monday night, working its way through Tuesday morning, there'll be a bit of a lull, especially south and east of the city. Once sunrise hits on Tuesday. But overall, a nice snowfall. It could break Philadelphia International Airport streak of not more than 1 inch for over 700 days. I do expect that to be broken because it's so cold to start. It'll be starting overnight. The atmosphere is plenty cold to stay all snow. So when you wake up Tuesday, hopefully your grass blades are covered. That's my rule for a nice snowfall. And schools and roads could be impacted. It's not going to be coming down too hard, so road crews should be able to stay up with it. But for safety's sake, I would anticipate, at least for, north and west of the city, for schools to have delays, if not closures.